Well, hello and welcome to the Smells Like Money podcast. Join me, Suzan Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. This week's episode of the DooDoo Diva Smells Like Money podcast is sponsored by Welcome to the Future of Industrial Automation with Riot SCADA. Take command of your operations like never before. From oil and gas to energy grids, Riot SCADA adapts to your industry, providing a seamless and powerful solution. Monitor, analyze, and control your processes with ease. Their intuitive interface puts the power of information at your fingertips. With scalability to grow with your business, customization to meet your unique needs, and remote access for control anytime, anywhere, they empower your control and drive your success. The future of industrial automation is here. Transform the way you operate with Riot SCADA. Well, hello, everybody, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are going to be visiting with Len Bland of Nano Gas Environmental. Now, as you know, we've had a number of episodes on nanobubble technology, which I find, pretty darn fascinating because I think this is something that is going to really be, the future is here now, but that it's going to have even more widespread applications to solve some of our largest challenges in municipal and especially industrial wastewater treatment and challenges. So thank you for coming on the show, Len.
Thank you, Susan.
So one of the things that kind of, came to my attention and why I wanted to bring Len on the show or bring you on the show is that your approach to nanobubble technology for treatment is a little bit different than some of the other ones out there that people may be more familiar with. I'm not going to name names here, but one of the things that, came to mind when we were having our initial talk was that you're not membrane based. And so why don't you give us a little bit of history of, your experience in this, how you developed your technology and some of the unique differences between yours and some of the other things that are out there on the market that people may be familiar with. And then we'll get into a little bit more about the ideal applications and why this may be a stronger candidate for certain things over others. And so with that, you have the floor, Len.
Great. Susan, I probably didn't tell you this before, but I was introduced to the technology as I was helping companies raise capital.
And oh, wow. Okay. No, you didn't.
I was so excited and interested about its potential that I just had to be part of it.
Oh, wow.
What I learned with that initial conversation was that the technology was coming out of trying to reduce heart damage with small bubbles at Wayne State University. And they actually eventually got that product into market. So they put small oxygen bubbles into the bloodstream to cure heart damage right at the time of a heart attack.
Oh, wow. Okay.
So we thought that was fabulous and we wanted that technology. We went out to meet with the company that we had been introduced to. And it turned out they didn't have a license to the Wayne State technology. And so we said, oh my gosh, this is so great though. We have to get a license ourselves. So we started pursuing that. And then we found out that the person that had worked on scaling that up from tiny amounts of water for the heart to huge amounts of water for wastewater treatment, had figured out why it was really working, what was really making the nanobubbles, and had solved some problems along the way, like getting clogged up at a hennery where it would just fill up with feathers and whatever other waste. And in the process of solving that, he figured out a way to have brand new technology that creates nanobubbles without clogging.
So how does that work? You were saying you weren't membrane based. We kind of, so explain that a little bit to the audience about, that distinct difference, because that was the thing that really caught my attention when we were first talking about this, is that you could take in very, very dirty water where some systems can't. Or maybe I could be misspeaking. And that also you use other gases aside from oxygen.
That's right. Every gas that we've tried has worked, from oxygen to nitrogen to carbon dioxide to methane to air. They've all worked. The way we do it is we dissolve the gas in a liquid under pressure, and then we go through our patented process that steps down the pressure. And by the time we release the water, the nanobubbles are created and they stay in solution. And the other beautiful thing about this is that we get these wonderfully high concentrations in a single pass. So sometimes some people are informed that, hey, to really get the high concentrations, you should do a multi-pass process. And we get such high concentrations in our first pass that a lot of times that's not necessary at all.
What do you mean by pass?
So we've talked to other people who have been advised with other systems that, okay, take the water that now has some nanobubbles in it and put it through the equipment again to get more, and put it through the equipment again to get more, put it through 5 times to get the high level that we're advertising.
Got it.
And that's not necessary for our treatment. In fact, we just put so much gas in the water that for some treatments, we use a side stream and we have a really high level of dilution. We only treat a really small bit of the water in order to get the concentration we're seeking in all the water.
Where do you see this technology going, as far as all the different types of treatment? Where do you think there's going to be a real sweet spot for this where it can make a difference?
Well, so when we originally identified the market, and when we did that, we thought we were the only ones creating nanobubbles. Yeah. So we identified 3 pages of big markets that we could go after. Some of those have been explored and some of them haven't. The ones that we're focused on are markets that we've proven commercially that where we treat dirty water, and that way, and where we deliver a high value for our customer, a high value for us, and we introduce sustainability even into dirty markets.
Okay, so we don't want to tip your hat here, but is there any specific market or type of application where you're finding that your approach with nanobubble technology can outperform or maybe a better fit than other things that are out there? I remember you were talking about that you're very well suited to certain industrial applications as well as municipal.
Yeah, we think we're an excellent fit where the water is dirty, where you may not have access to fresh water, and where the industry maybe even has a bad name when they use fresh water. So those would be things like, we think there's a very good fit for nanobubbles in general in treating shallow lagoons, because bubblers just the bubbles rise too fast. But then if they're dirty, then it makes sense for us. And then certainly oil industry wastewater called produced water.
Hmm.
Uh, a lot of times it's coming from desert regions, and the oil industry already has a bad reputation for using fresh water. And there's no need for them to do that. We can reuse the water that we're cleaning. We can start with the dirty water. So that works well. Uh, in addition to just our technology, we've also got quite a bit of intellectual property that also creates another moat around our technology and what we might do with it. Because as we explore certain areas like using nanobubbles for oil well stimulation, we've been first and we've recognized the opportunity and we've been able to create some intellectual property around that.
Interesting. I'm looking at the pictures that are behind you. Other folks can't see this, who might be just listening in, but there's something where it says 1 day and 4 day. Tell me what is that behind you that we are seeing?
Yeah, so we treated a wastewater lagoon in West Texas, and I could bring up a full size screen for you where you could see that.
Right.
Uh,
Let me give
oh,
you
if
a
you, yeah.
screen sharing capability so that you can actually do that. And please, for
So
those of us who are just, tuning in via audio, if you can describe what is coming up on the screen, please.
So I think there's been quite a bit of understanding now in with some press releases that that are showing that you could nanobubbles are great for making algae disappear
Right.
or for getting rid of the stink, right? So what we're showing is within 4 days in this sewage lagoon that we treated, it was a 300 home community. They were told it was going to cost, they were going to have to dredge the lagoon. It was going to cost them $1 million to dredge the lagoon. Uh, so they could see algae. It was so thick, bugs were walking on top of it. They were releasing methane, and they had sludge islands building up. So the articles that we've seen have said, hey, yes, you can get rid of the algae with oxygen nanobubbles. You can get rid of the stink. But we're taking that a step further because we're getting the right levels of oxygen into the lagoon, running it over a period of time to also enable the microbes to eat up the sludge on the bottom. And so then you restore the lagoon to the extent that there's organic sludge that those microbes will eat up. And for this particular location, the microbes consume 95% of the organic sludge, and it was restored uh, back to uh, back to full operation, where sandhill cranes and fish and turtles are thriving now in the third lagoon. Lagoon systems typically have 3 or 4 parts. The sewage flows into the first one, and then the third one is where you have the cleanest water.
Right. Right. So how big is this unit? Like what is required to, deploy it at a typical site?
So we have a mobile unit. It fits in a trailer.
Oh,
Uh,
wow. Okay.
it rolls out, and we can, set it at a lagoon or set it to stimulate an oil well. An oil well might take only 1 day. A lagoon might take, if all we're doing is algae, it might take, depending on the algae, 3 or 4 days. But if we're doing cleaning up the sludge like that, it depends on how much sludge there is, how thick it is, and how fast we can get that bacteria to grow. But it might be, several months.
Okay.
Uh, Now, if we're treating oil industry wastewater, there's a never-ending flow of that. So we might
Right.
set a unit out in treating oil industry wastewater. That might be a more permanent situation.
What
But
about
still,
it?
the size of the unit is about, it'll fit in a trailer, and uh, you know, we can actually put multiple pieces in a trailer, but we've got one piece for the oil industry that's handling 15,000 barrels of produced water per day.
Okay. All right. So now, what about applications for things such as industrial process water, like in food and beverage production, metal finishing, things like that? Does it have to be organic? Well, obviously, with oil and gas, no, it's not organic. But let's just say in metal finishing or dairy production or any of the, food and beverage, like breweries, their process water can be extremely caustic. Can this be incorporated into an on-site tertiary plant before they release to the main municipal streams so they retain their compliance?
The answer is absolutely yes. In nanobubbles will have some level of energy efficiency compared to standard methods, but the way that a lot of the standard systems are built, they build really deep ditches or oxygen ditches or ponds or really deep tanks, so that when you're using a regular fine bubbler that's really inexpensive, those bubbles of oxygen have time to absorb into the water when you have a lot of depth. And so the beneficial use is not as great there. And that's what I mean, deriving a lot of value. But
Right.
let's say you're at one of those industrial places, let's say a beverage or food and beverage waste, and you just have such high levels of dissolved oxygen, high levels of BOD or
Right,
COD,
beauty, right.
that you just can't get the enough oxygen absorbed into the water. That's where nanobubbles can really work. And we think that they're a great solution when somebody's at or near capacity using your standard fine bubblers, and they're thinking, oh no, we're going to have to dig a whole nother ditch, and it's going to cost $1 million to millions of dollars to expand our plant. Then okay, let's introduce the nanobubbles, because now you're making, again, delivering high value to the customer instead of having to spend those millions.
Right. Now, with this technology, is this something that is purchased as a capital equipment, capital improvement, or is this something that's offered as, like the model, like software as a service, like treatment as a service, where it's on a lease or subscription basis?
So for right now, we're starting with subscription as a service. And the reason why, first of all, the oil industry absolutely accepts that model. They rent things all the time. It's not as common in wastewater treatment. A lot of people want to buy equipment there. The reason why we think it's important for now is that we think there's a poor understanding of the market, how nanobubbles work, how much to introduce, the entire solution that you need to set up. How much bacteria do I put in? What was the status of the pond beforehand, or the status of my wastewater treatment system beforehand? We think people are still learning a lot,
Right.
and that has resulted in a lot of failures when equipment is sold. So I can't tell you how many people say, yeah, we think you're right. We hear that that system failed, we just couldn't keep up with the chemical washing of the membranes that were required. Or people are, this is what I love. Somebody will come to us, Susan, and say, I want a unit that does 50,000 gallons a minute, or 5,000, or whatever it is. And I go, great. How much gas, how much nanobubbles, how much oxygen are you putting in? Oh, I don't know. And so I say I have this beautiful system. I'm sure it's creating some nanobubbles. I can sell it to you really cheap. It's called a hose. So, so,
I like that.
so we have worksheets. We want to do the work with our client to make sure they're successful and to make sure they're going to save money or make money, depending on the market.
Right.
So if they're not going to save money or make money with us, then we want to steer them a different direction.
That it may not be the right fit for what they're trying to solve.
Right.
All right. Well, Len, thank you for introducing another type of nanobubble technology, another option for people to be, exploring for treatment, because I really do think that this is something that definitely needs to be looked at. It needs to be considered, in my opinion, in my humble opinion, I could be wrong, in, retrofits, in upgrades, when there's compliance issues, but also maybe let's start considering, is this something that should be incorporated at the beginning when you're looking to bring a new plant online, a new facility online, as part of the overall mix and design build?
It's funny that you say that because we definitely think that. And, we went to WEFTEC one year. We were walking around and, somebody showed us their best fine bubbler and they said, this gets 30% oxygen transfer efficiency. And we go, wow, is that using air or oxygen? And they, well, that's when you use pure oxygen, right? So they're really around 6% oxygen transfer efficiency. And with nanobubble system, you could be up around 95% oxygen transfer efficiency. So we're walking around and we came across an engineering firm designing a huge multi-million-dollar plant for a major city. And we said, why are you going to put these oxygen ditches in and do it the traditional way when you could have this huge benefit of using nanobubbles? And they said, well, it takes us about 5 years to design all this, and we kind of already made that decision, even though they were still 4 years away from ever even breaking ground. So I think it's gonna take some time to convert the industry. But I personally believe that every wastewater treatment plant should be using nanobubbles, that every produced water treatment in the oil industry should be using nanobubbles. That's hundreds of billions of dollars worth of treatment a year. And that, anybody who is thinking of water treatment, with aeration should be considering a solution based on nanobubbles.
Right. It's taking aeration to a whole nother level. I mean, there's lots of things that generate these bubbles and create the aeration, but this is just, from what I'm understanding, it's not, you think of nanobubble, you just think, oh, there's lots of bubbles. No, you can't even see the bubbles. I think that's the other misconception, is you can't even see the bubbles. And it's changing the chemistry.
Here's what I started telling people that are getting their first introduction to this, that aren't experts like you and your listeners. I started telling them, first of all, we clean dirty water with tiny bubbles. So then they go, oh, I need to learn more. What's that all about?
Right.
And then the second thing we tell them is it changes the way water works.
That's a great way of describing it.
Because it's not just a biological difference with getting more oxygen in the water. It's a chemical difference with changing the ionic and zeta potential of the liquid. It's a physical difference with having these nanobubbles carry a negative charge and wanting to stick to, let's say, rock in a subterranean formation. So there are physics and chemistry and biology can all play a role depending on what you're trying to do. And so it really does change the way water works. So, you put enough nanobubbles in, you're changing the specific gravity of the water, you're lightening it up. So now imagine processing stormwater and you're trying to get all those particles to drop out. You can introduce flocculation chemicals. Or what if you just lighten up the water and suddenly those particles are heavier?
Trying to do things in a greener, more sustainable way. It's, I love any kind of technology that, chemical companies going to hate me for saying this, but anything that is going to be removing having to put more chemicals into what we do, using more chemicals, because, well, for a whole host of reasons. We don't know, are we consuming, as people that consume water, Are we consuming those chemicals or are they disappearing as part? We just don't know. And so if there's something that can give us what we need, healthy, clean water, without having to introduce a chemical that we don't know what is going to happen when that consumes, even if it doesn't go into our body, is it going to affect the environment? Is it going to affect the soil? All those unknowns. It's just, one of the big things, not to get on a political bent here, but when we've introduced species into, we're having this problem in this ecosystem, let's introduce this thing. And then it winds up backfiring on us. What they call non-native invasive species. And so maybe are we doing that when we're introducing chemicals because we're trying to solve a problem because we need to solve the problem, but are we actually creating a greater problem that we don't know that we might be creating by trying to solve? What is it? The side effects are worse than the thing that we're trying to solve.
Here's what I love. So sometimes we hear, let's say, we're not going after this market, but sometimes we hear, hey, there's not enough oxygen in our water coming out of our plant, and that's going to cause fish kills, right?
There you go. Yeah.
Okay, a little bit of nanobubble aeration, and we make the fish really happy. So there's lots of opportunity.
Yeah, I love it. I love it. Well, if people are interested in learning more about Nanogas Environmental, how can they get in touch with you, Len, and find out more about what you're doing with this amazing nanobubble technology?
Yeah, well, the best way to get in touch with us is to go to you can start with our website, nanogasenvironmental.com. And the other, I'm going to if I can share my screen again, I'm going to put my contact information. I'd love it if you can.
Sure, we'll also have that. Yes, you can. You can share your screen. And we also will put that in the show notes for you. So for those of you who are seeing this, nanogasenvironmental.com, Len at NGT Energy. And also, right. Len, you're on LinkedIn, which is how we found each other. LinkedIn, that great connector of all people in business. So look up Len Bland there. And the number is here on the screen. And Len, I want to thank you for, being on the show, sharing information about this technology, and, giving people an opportunity to learn more about all of the different facets of nanobubble technology. And just, better educated consumer that, we need to start embracing some of these newer technologies and seeing what's out there and what can be done. And thank you again. Really appreciate it.
Well, I can't thank you enough for allowing me to be on the show, Susan. This was fantastic. And what you do for the community is really great.
Well, thank you very much for those kind words. And thank you, listeners, for tuning in. And hope to see you on an episode upcoming. We've got a lot of good stuff lined up in the pipeline. And so until next time, keep it flowing. And a very special thank you again to this week's episode's sponsor. Welcome to the future of industrial automation with Riot SCADA. Take command of your operations like never before. From oil and gas to energy grids, Riot SCADA adapts to your industry, providing a seamless and powerful solution. Monitor, analyze, and control your processes with ease. Their intuitive interface puts the power of information at your fingertips. With scalability to grow with your business, customization to meet your unique needs, and remote access for control anytime, anywhere, they empower your control and drive your success. The future of industrial automation is here. Transform the way you operate with Riot SCADA. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.